Hola a todos, muy buenas tardes. Soy Nicole Fantahufa, and today I'm going to continue in English. This is How to Be a Gish. I am a developer advocate at K6 Grafana Labs, and I've been in performance testing for over a decade, and I've spent most of my career as a performance test consultant. I also play several role playing games a week. This year, I've already played 60 games so far, and so I thought it would be fun to think of testing in the context of role playing games like Dungeons and Dragons. This is how to be a gish as a tester. So, this is the overview of what I'm going to talk about today. First, why is a gish the best way to level 20? Secondly, what that has to do with testing. Third, why a gish tester is irreplaceable and valuable. And also how to incorporate different types of testing in one script. So first, just a little bit of an introduction here. D&D or Dungeons and Dragons is a tabletop role-playing game. That means that it's a game that you play with friends without a board, and you act like you're a character in a fantasy world, so not as yourself. That's why it's called role-playing. You're playing the role of someone else. And at the beginning of the game, you usually start by selecting your class. Now, a class is something that affects the rest of what you're going to be able to do. It affects your starting abilities, like whether you're more intelligent or whether you're stronger than you are intelligent. And it's also going to affect the kinds of gear you wear and the way that you're going to have to act for the rest of the game. So, in a way, it's kind of like a profession, but the fantasy edition of that. It's also a form of specializing. Now, usually, as professionals, we are rewarded for specializing. Let's take the case of this person who many of you might recognize. This is Wolverine. Wolverine is almost certainly a fighter. That's the class that he would have if he were a D&D character. He has almost single-minded purpose. He has this skeleton that's infused with adamantium, and it's all over his body. And so it makes him extremely resistant to pain and other physical attacks. So his single-minded purpose is to attack physically. Now, Wolverine is an example of a specialist. He's not great at other things, right? Like, he doesn't have any magic. He's not really a great leader unless it's the leader of a battle. And he's just this sheer animalistic force, but he is excellent at that. So, what happened when he met Magneto? Magneto is a mutant whose power is that he can control all metal. Unfortunately for Wolverine, that includes adamantium. And so Magneto, with a wave of his hand, was able to stop Magneto in his track, was able to stop Wolverine in his tracks. That's the problem when you are specialized. You might be very good at something, but that also means, normally, that you also have some weaknesses that can be exploited. Now, this is Professor X, aka Charles Francis Xavier in English, or Javier. He's head of the X-Men and the Xavier School for Gifted Youngsters. And Professor X is a specialist too. He is one of the most powerful X-Men. Probably the only X-Men that's more powerful than him is his protege, Jean Grey. But he's a genius in his own right. He's a magic user slash telepath. And physically, unfortunately, he's quite weak. You can see here that he's in a wheelchair. That's because he has a neurodegenerative disease. And so if people find a way to block his telepathic abilities, such as Magneto's helmet, Emma Frost's diamond form, or Stryker's neural inhibitor helmet, then he's next to useless, really, because physically he doesn't stand to win in a confrontation that is more physical than it is mental. So what we're finding out is that being a specialist isn't always a good thing. If we choose only one of the available D&D classes, then that's being a specialist, but that also means that we're choosing what not to be. In fact, to specialize is to limit ourselves because we all have limited time. In an ideal world, we'd go through every class and do all of the things and be just as good at one as we are at everything else. But the reality is that we don't usually have the time or effort or budget to do all of that. So we have to choose what not to learn. And we do this all the time at work too. In fact, a lot of the career advice that we're given seems to revolve around picking a topic that we want to get good at and then just focusing on that for the next few decades. So, how do we reconcile that typical advice with the inherent weaknesses in specialization? So, why is it that sometimes being a specialist seems to be like a good thing, but other times it's a bad thing? Well, here's something I've noticed. In an environment of uncertainty, the generalist trumps the specialist. So that means that when things are certain, stable, reliable, and consistent, it pays off to be a specialist because you know you will know more than than a generalist would for that job. And in fact, you'd be the best person for that job. The question is how long that job will exist and how long that job description will exist and not change. Because when things are not certain, being a specialist kind of sucks. It's putting all of your mental eggs in one basket. So you can see here in the slide, the person on the left has all of these differently shaped gears that can be used to power many, many things. And the person on the right has a single gear, a very big single gear, but still just one gear. In this situation, a generalist is way more marketable and intrinsically more valuable because a generalist has more options. We can kind of see this in startups as well. If you look at any startup with less than 10 people, you'll notice a funny thing. All of them are generalists. And that's because startups are in a very uncertain environment, probably one of the most uncertain environments. You're not sure if the business model will stand up to the chaos of production and the whims of the masses. Nothing is for certain. And in that situation, it's way better to have somebody who can adapt and change their roles depending on the needs of the startup. When you're in a startup phase, things change really quickly. So what does this mean for our D&D character and for our X-Men characters as well? This is Storm. Now, the generalist D&D character is often referred to as a gish, and that's the word that I put in the title because it originally referred to a race called the Githyanki. But a gish is a character that is both a fighter and a spellcaster, kind of like the best of both worlds. Someone who can stand toe to toe in physical confrontation, but also be able to have ranged attacks and do other things to control the battlefield, other than just going out there and physically fighting. And Storm, aka Aurora Monroe, among the X-Men, is the best example of a gish. So you might already know that Storm has atmokinesis, which is the ability to control the weather. She can also teleport. She can create a portal out of lightning, go into it, and also have other people go there as well. And she has energy vision because she sees the world in different types of energy. And she also is telepathic. Well, she's not telepathic herself, but she does have telepathic resistance. But what you might not have known is that she's good at more than just these mage centered spells. In the absence of Professor X, she stepped up as a leader among the X-Men and proved to be a capable tactician. So she's not even the most powerful. If you had to name the 5 most powerful X-Men, it's unlikely that she would make that list. However, she's the best leader after Professor X, and she was the only one who had the guts to actually try to step up to those very big shoes. She's also the Queen of Wakanda, which means that she protects an entire nation and leads her people, and she's also a diplomat for Wakanda in other places. She was a thief when she was growing up, so she's very sneaky and stealthy and can pick locks with the best of them. She's had years of training as a fighter in close combat. She trained under Black Panther, Wolverine, and the Ronin Yukio. She's great with knives and the bow staff and swords and various firearms. She's also fluent in English, Arabic, Swahili, Russian, Japanese, Wakandan, Yoruba, and more. And by the way, she's a pilot. Storm is the quintessential generalist. In contrast to X-Men like Wolverine and Professor X, she has a lot of skills, making her a bit of a Swiss Army knife of the X-Men. She excels in most situations, even though she's maybe not the best in any single one of them. So, how is this relevant to testing? Well, it turns out testers are generalists. Testing is a multidisciplinary practice. We're technical, but we also have to be creative. We are systematic when we do our tests, but we also have to be intuitive and think about exploratory testing and other kinds of tests that are informed by experience. We see the big picture and the finer details. And we care about quality, and the concept of quality itself is just so abstract and very general. Tech moves quickly, but testers must move faster because many of us move from project to project. We're likely to see multiple programming languages, frameworks, and platforms in our career. And because we often have the tendency to work on things that haven't yet fully been released, then we kind of have to stay one step ahead of the tech. We are the quintessential Jacks and Jills of all of the trades. And the way we test changes constantly, or at least it should, because changes in code and infrastructure should change how we test. For example, we've seen now the evolution from server virtualized servers to containers to Kubernetes pods. We've seen the industry go from monoliths to microservices, and then there's kind of like this shift to go back at some points. There's centralized networks, and we've gone now to distributed, and then the next step is like federated networks. There are new fields like observability and chaos testing and site reliability engineering that aren't exactly in our wheelhouse but are certainly overlapping with testing. And also, production is uncertain. We were talking about generalists triumphing in uncertain environments, and production is definitely uncertain. Try as we might, we can't fully say what's going to happen in production. We can just do what we can to predict what we think will happen, but it's never for sure. So, how do we grow as specialists in addition to growing as generalists? Well, let's look at the word performance. If we specialized in the front end, this is where we would be focusing. We'd be looking at how quickly something renders on the screen. We'd be looking at whether we have something to interact with, even if the page isn't loaded. We're looking at automating the user interface. We're looking at things above the surface of the sea. If we just remained a specialist in this, then we would never go on to the following slides, such as this one. Now, this is the back end, and if we specialized in the back end, performance might mean looking into low response times or the microservices based architecture and how different services work together, where the traffic goes, for following the flow of traffic from one to the other. It could be looking at database optimization or making sure that the load balancer is configured correctly. If we only focused on the back end, then we're only looking below the sea. We're really missing out on a lot above the surface as well. And we'd also be missing out on everything else that's in the sea, because in the previous two slides, we're only looking at the same application, what's above and what's below. What about all the other things? We could also think of performance as how well this ship performs in the wider ocean, where there are waves and maybe even other vehicles for us to run into. So, in this context, performance could mean having replicas for all essential services, being able to withstand unexpected load and outages, or having information saved for later processing in the case of an outage. Performance here is more about building confidence in the face of uncertainty and turbulence. So, if we were going to specialize, which one would we choose? Well, that's really a bit of a trick question. ¿Por qué no los tres? The main reason that we don't do all three in our tests is that those are three very different types of tests. And it simply takes a lot of time and effort and budget to learn all three. Those could be three different careers. It's browser automation, API load testing, and chaos testing. So there is definitely a trade off. If it's difficult to specialize, if it's difficult to generalize, then the trend is going to go towards specialization. The problem is that the type of tool that you choose is going to affect to some degree what type of testing you do, right? So if you have a browser based tool, then you're going to do browser automation and you're much more likely to find defects in that area. When all you have is a hammer, then everything looks like a nail. So what's a generalist to do? Now we're going to talk about K6. Now, K6 is the company that I work for, but in this entire presentation, everything that I'm going to mention is going to be about the open source free version only, because at K6, open source is a given. It's more than just like a business model, it is a philosophy. K6 is free, open source, and proudly so. K6 is also written in Go, but scripts in K6 are written in JavaScript. And that was intentional because Go has a lot of performance benefits, but also JavaScript is almost ubiquitous as a scripting language for both developers and testers. I talked a bit about how Go lends it a lot of performance benefits, and it is definitely built for performance, not just from the benefits of Go, but it's also supported by a team that is constantly measuring and improving performance. I really hate when we don't even test our test tools, because I think that if we don't test the tools themselves, then how can we trust them to give us accurate results later on? So K6 happens to be way better in terms of resource utilization than any Java-based tool, just from the fact that it runs on Go. It also has multiple execution modes. So there's local and there's distributed, so it can be run in a Kubernetes cluster, and also in the cloud. And it plays well with others. It integrates with GitHub Actions, CircleCI, GitLab, Jenkins, TeamCity, Azure Pipelines, and many more. I can't really keep up, but it's super composable, and that's what we're trying to do. We're trying to build something that you can take for free, drop into what you're already using, and have it just work. No proprietary lock-ins. And by the way, we were acquired by Grafana Labs last year, almost a year, I think almost exactly a year ago, we were acquired by Grafana Labs, which means that in addition to all of these integrations, we now have Grafana as an observability platform and visualization tool. And you can also extend K6 easily, making it more than just a load testing tool. It's more like a performance or reliability testing platform, which makes it an especially great tool for generalists. So let's talk about the different things that you can do in a single K6 script. And we're starting with the underbelly of the sea creature, which is load testing, which is what K6 is most known for. Now, this is a simple K6 API load testing script. This is you can just take this and save it as a JavaScript. I've put this under load testing, but don't let that put you off, because you can actually just use it to test APIs, for example. And in this script, I'm importing HTTP, and then I have a single request within the default function, which is an HTTP GET. It retrieves this document, which is on our test environment. So there's a lot more that you can do to this. You can add checks, you can add think time and all that. I just wanted to show you the very basic way to use it. But even after you add all those things, there's just a lot that API testing can't show. So what if we want to see the things that are above the surface? Well, I did mention that there are extensions in K6, and one of them is called XK6 Browser. Now, to be able to use an extension, you can use something called XK6, and the X stands for extensions. After you install XK6, you can use this build bundle like we've got here. You can select the extensions that you've got, and then you can copy this command and just paste it. Now, after that, what this is doing is it's building your own custom binary of K6 that's built with whatever extensions you've selected. The reason that we're doing it that way is because we definitely don't want to fall into the trap of just putting absolutely every single feature into a bloated binary when most people don't only use like 10% of what those features are. So instead, our philosophy is to keep the core binary as small and lightweight as possible, and then you can add stuff in according to your needs. So once you execute this command, you'll have a custom binary of K6. You can also do this within your pipelines to build on the fly. Now, for the second level, this is the browser automation maneuver. And unlike the first one, you are going to need to create a custom binary because XK6 browser, which is what this command is for, is an extension of K6. XK6 browser is super cool because our CEO developed the prototype. I always love when CEOs or high-ranking people in a company still get their hands dirty. So our goal is feature parity with Playwright, if you're used to that, but it's also very similar to things like Puppeteer. It is a browser testing extension, but it's still using K6, which means that you can script browser tests using XK6 browser and K6. So here's what that looks like. So here in the first one, I'm importing the launcher from XK6 browser, and then I define a browser, context, and page. And in this case, I'm using Chromium, and I'm saying that I want this script to run headlessly, not headlessly, which means that I want to be able to see things pop up. So you'll actually see XK6 interacting with elements on the screen. So the difference is that in the previous one, you can see in the API script, it's just on the protocol level. It's sending an HTTP request. But this browser script looks for an element on the screen. So it has access to the DOM elements, and it is looking for a link that contains the word register, and then it clicks on that link. Now that's cool because you're not specifically having to define the URL. So if the URL changes, well, it doesn't really matter. You're still going to be able to click on it if you're using the script. And then it takes a screenshot of whatever page resulted from that click. And then you close the page and the browser. Now, this is still just using a K6 script, and it's still just written in JavaScript. The third thing that you can do is chaos engineering. So this is just branching out and adding different kinds of tests to your test script. And for chaos engineering, we have another extension called XK6 Kubernetes, which lets you run Kubernetes commands from within a script. And this is the command for building a K6 custom binary with XK6 Kubernetes. Now, this XK6 Kubernetes extension brings conditional logic and also imperative logic to the mostly declarative world of Kubernetes, so you get the best of both. It allows you to change your application as part of your test or even in response to events that occur during your test. So you have this cool cycle where the environment informs the test, but then the test also informs the environment. So you get this kind of test that is very adaptive. And this extension really broadens the scope of a test beyond just performance testing at the API or browser levels. Here's an example of an implementation of this XK6 Kubernetes extension for chaos engineering. So here I'm importing these libraries, and in the default function now, I'm terminating a random pod with this namespace. So it's really important to only have this go through the pods that are in a certain namespace so you don't accidentally terminate things that are running in production. But this is just one use for it. You can also do CPU and memory starvation. And in the future, we want this to be able to do network things like creating a black hole attack and that sort of thing. But imagine having this and even being able to set conditions for it during the test, like only do this after 100 users have logged in or something like that. So now I've shown you three different types of scripts, right? But we're talking about being a generalist here. We're not talking about running each of these scripts independently, although you can. We're talking about running them all in the same script. And here's what that looks like. Now this command here has both the XK6 Kubernetes extension and the XK6 browser extension. And then the protocol stuff is just baked into K6 and is native. And what I'm doing here is I exported those three separate scripts, and then I'm importing them into kind of like a runner script. And in this runner script, I'm defining three different scenarios: protocol, browser, and chaos. And I can control them separately and schedule them according to when I think they should run. So for example, with the protocol level script, I want the executor ramping VUs, so that means that I want virtual users that start at a certain number and then increase from there. And I'm even setting stages here. So this means that I'm starting with 0 virtual users, and then over the course of 1 minute, this is the ramp up, I'm going to go from 0 to 10 virtual users. And then for 3 minutes, that'll be the steady state where the script holds steady at 10 virtual users and then begins the ramp down for a minute where the 10 virtual users goes down to 0. So I purposely used low numbers just in case because this was against the test environment, but you can change any of these durations and virtual user numbers. And then the second one here is the browser scenario. This time I just want, because I'm running the browser test not as a load test. I just wanted to be able to capture some front end metrics. And the idea is that the protocol test, the protocol scenario, is generating majority of the load. So I was happy to have the executor be constant virtual users, meaning I just specify a number of virtual users. It starts at the beginning and then just runs for this duration. So it will run for 5 minutes, which is the duration of the entire test. And now this third scenario is chaos. And the executor here is per VU iterations, meaning I'm setting a number of iterations that each VU, each virtual user will run. So because this is chaos and I don't really want there to be too many pods being terminated all at the same time, because that can kind of conflate the results, right? You want to be able to clearly show, if you're just changing one variable, you'll be able to clearly show the effect of that variable changing. So the way that I set this up is I have one virtual user running one iteration of it, meaning one random pod will be terminated, and I am setting the start time for after the ramp up. So I don't want it to happen in this beginning part. I want it to happen when there are already 10 virtual users, the full load, that are on this application. And you see now that from 3 different scripts, we've put it all in one. And it's all run using this command. Now for each of the previous scripts, you can run them separately still, but this is running them all together. So this was a very specific way to become a gish tester by combining 3 typically separate kinds of testing in one script. But this isn't the only way that you can be a gish tester. First, you can increase your range. This is from a book I read called Range, and it said that the people that are that have range, meaning people who can do things beyond what their job description says, are actually the most sought after, because it's our ability to integrate different types of knowledge that sets us apart from machines that are the ultimate specialists. So we should consider other types of tests, not just the ones that you've been hired to run. And the mark of a good tester is really caring about the overall application quality, not just the part that you've been assigned to. Secondly, you can improve your soft skills. I think that our primary job as a tester is to communicate and communicate well. We're always communicating. We're communicating to developers and making sure that we understand what has gone into the code. We're talking to the business analysts and talking about the requirements and whether or not they're feasible. We're talking about test objectives, we're talking test scenarios and then test results and then suggested improvements. And I think that soft skills are a bigger part of that than we might initially be tempted to think. You can also take notes on projects that we've worked on because our memory is limited as well. We are not machines. And I think that there's this trap that we can fall into where when we're doing something every day, we are so sure we will never forget it because it's like almost second nature for us. But the reality is that maybe in 10 years, we are not going to remember it. And taking notes on things makes sure that when we go back to those notes, we'll remember, we'll be right back where we were and we'll be able to pick up where we left off. And then we can also learn to use different hats. There's an author named Edward de Bono who wrote about 6 hats. And the idea is that a hat is a different way of thinking. It is something that you put on because it's like a conscious effort to think a certain way. And it kind of functions as a forcing function to shake you out of a mental rut. Because otherwise we get stuck in the same thinking patterns. Putting on a hat can stimulate our creativity and force us to come up with different approaches to problems that we might not have considered. And here's an example from performance testing and how I thought it could be incorporated into what we do. So, for example, the blue hat is metacognition, which is thinking about thinking. Are we focusing on the right thing? Is this the right approach? What are we even doing here? When we put on that hat, we question assumptions about the process. The white hat is the hat of facts. So, when we have the white hat on, we think of checking the logs and forgetting about emotional attachments to certain outcomes. What do the facts actually say? What do the results say? What can the data tell us? The red hat is about gut instincts. And it's easy to dismiss the red hat because it seems very wishy-washy, like, that just doesn't sound right. But the reality is that our intuition plays a big part in how we function as testers, or really in any profession, because experience is not as easy to quantify, and experience informs our intuition. The black hat is the hat of criticism. It is being able to look critically at what we've done or sometimes what other people have done, though pointed out in a nice way. We can think about what other kinds of tests we should have done, what we could have done to improve it. The black hat is always on the lookout for ways to improve for next time. But it should be balanced with the yellow hat, which is the hat of positivity, which is thinking about the things that did go well and focusing on the things that maybe will save our butts if something happens in production. Like, hey, our alerting worked. We might have let a defect slip through the cracks, but at least we know that we can be confident in our alerting. And the green hat is creativity. So thinking of out of the box solutions that can be extremely useful, like asking support, because customer support people know the product maybe more than anyone, more than developers even. So here's an illustration of the benefits of being a gish. We've got Wolverine on one side. These are called stat blocks in the D&D world, by the way. These are the lists of abilities that each person has. And Wolverine is a DevTools expert and does one thing and does it extremely well. Whereas a gish, Storm, is more like this. Lots of different actions and has this trait where she automatically reports defects that she just that are just within her proximity of her without even having to take an action. Storm is someone that is good at everything and not the best at anything. But if you have to choose one or the other, I think Storm would get the job. So let's just wrap up here. First, testing is a generalist discipline. A good tester considers quality from different perspectives. Secondly, to thrive as a tester, we can become a gish like Storm. Aside from the fact that she looks really awesome here, Storm happens to be somebody that can excel in any situation. And as testers, that's the situation, that's the kind of skill that is going to make us invaluable. Another thing we learned is that we should prefer multi-purpose tools with range, which means that we should expect more from the tools that we choose because the tool that we choose is going to inform as well the kinds of testing that we do or even the kind of quality that's at the front of our minds and the team's minds. Because if our tools only look for one thing, then you're only ever going to find that one kind of defect. Tools that are more multi purpose are really important because they encourage out of the box thinking or maybe just lateral thinking, things that aren't quite what we were looking for but still have significant overlap. And lastly, we should consider the big picture of quality. There's a tendency to get very nitpicky as a tester because we want to rack up the number of defects, but we should be looking as well to increase the different types of defects that we're reporting because it's only by pointing out those things that we're going to find problems that are unexpected. And one way that we can do that is by doing browser automation, API load testing, and chaos testing in one script. It is easier than you think, and it definitely leads to a lot of benefits. So here are some links. Thank you everybody for listening. I just want to point out that this repository, Nicole van der Hoeven /ExpoQA on GitHub, has all of the scripts that I showed here if you want to download them and try them for yourself. And it has a link to these slides as well. Muchas gracias a todos and have a good rest of the conference.